Hello everyone, welcome to the first coding tutorial here on my channel. My name is Alex, welcome. Today we're going to have a short talk about linked lists, how to create one from scratch in C++. Let's get straight to business. Now, why would I choose C++ instead of some kind of simpler language like, I don't know, Python? Well, that's a good question. It's just that C++ is difficult, which is why I'm automatically attracted to it because I like difficult things. Helps with growth, of course. Now, I'm very happy that I chose C++ because this project actually made me understand pointers way better than I did before. So I'm very thankful for that. Let's just go straight in. So I'm just going to explain visually. If you're like me, having a visual representation of what we are implementing helps you a lot. Like, it definitely, this is how I work. This is understanding it visually helps me a lot, right? So I'm just going to explain it real quickly here. You may already know or be familiar with this, but if you're not, this should give you like a general idea and understand how linked lists work and why maybe you prefer them over arrays or hash tables in some instances, right? So what are linked lists? So linked lists are basically made up of nodes, right? Please ignore my absolutely beautiful artistic skills. Let's just focus on on the important stuff, right? So we have nodes. Linked lists are made up of nodes. So what is a node? A node is basically just a collection of two variables. Basically, we have some sort of data. So a node holds some kind of a data, which in this case it can genuinely be any data type, but we're just gonna work with integers because they're the simplest and easiest to get us going, right? So let's say this guy's data is going to be 5, for example, and the second part of the node is a pointer, right? A pointer which points towards the, guess what? Next node. Very awesome. So this guy also has a data, so let's say, I don't know, 7, right? And this guy also has a pointer, right? Who would have guessed? Towards the next node, which also has some data, of course. Let's say 9. And let's say if this is the final node, then this guy points towards null, right? This is because linked lists are null terminated. So if the last node points towards null, then we know it's the end of the list, right? We're just gonna keep this in mind because we're gonna use it in about a few minutes when we're going to implement the whole thing. We're gonna set it up. This guy, the beginning node, is called the head. It's obviously the beginning, so it's the head. And this guy is called the tail because it's the end. All right, so how could we go about implementing this? So we essentially have to implement two classes, right? We have to implement the node class, which is essentially this structure right here. We have to implement it. And then we have to implement the actual linked list itself. We're going to create the first node, which is going to be the first class, which is going to be the node, right? So as we've said, the node has two parts, the data part and the pointer part, right? So we're going to have to create two variables, which is the data part, right? And the pointer towards the next node, right? So we're going to create a pointer towards next node. Pretty awesome. Let's just also initialize these guys, so we're not gonna run in any kind of issues. There we go. And we should also make these guys public, of course. Then we're going to have the constructor, right? So we're going to take in int data and node pointer towards the next node, and we're going to create a node, right? So this is gonna be this data equals data, and this next node equals next node. So essentially, when we are receiving the data from the actual constructor call, when we are creating a new object, we're gonna just assign it to this data right here, and exactly the same thing with the next node pointer, right? So that was about it with the node class, and now we're going to go ahead and create the actual linked list, right? We're gonna have class linked list, no parentheses right here. So let's think, what do we need? What do we need in order to create this? So we know we have a head node and a tail node, right? So let's just try and actually implement these. Node pointer is gonna be the head, and the node pointer the tail, right? Because when we create a list, even if it's just one item, in which case the head is also going to be the tail because it's just one item. So let's just create a constructor, right? And again, we should make this public. So linked list, we're gonna need the, when we are creating a linked list, what do we need? Do we need for someone to actually input us the nodes? No, we don't need that because we can just create them ourselves inside the actual class. So there's no need for someone to explicitly add the nodes in there, right? They're gonna just be created here directly, right? So we're just gonna have the int data, which is what we want to insert in the actual linked list. So when someone creates a linked list the first time, it's gonna have just one item, right? So we can say head equals new node of data, and the next node, considering it's just one, is going to be a null pointer because there is nothing after it, which in this case means that, as I've said before, the tail is also equal to the head because it's just one item, right? And then the next thing which we could also implement is having some kind of a length for our linked list, because that's also going to be pretty easy for us to understand exactly how many items we have. So we can, when we're adding an item, we can just say length equals to 1, right? When we are essentially creating this, creating a new linked list, obviously. Right now, we have enough functionality to actually be able to instantiate and create a linked list. So let's see. If we create a linked list, let's call it L equals to a new linked list. We need to create, we need to put in some data. Let's call it 5 instead, right? And we also have to use this pointer. There we go. So we could access standard cout, the head, which is also the tail. In this case, we could access the data. So let's see if right now, as far as we have gone this far, if our implementation is correct. Let's see. We should get 5, right? There we go, 5, awesome. All right, so now that we've actually implemented this, let's just actually start implementing some functions so we can actually do something with it, right? So let's imagine we have one node, right? Let's say we have some data in here, 5, and a pointer, which is gonna go towards null, right? You have just one item, this guy, the 5 right here. Awesome. There are two really cool functions which we can implement, which are called Prepend and Append. And I'm guessing you can already tell by the placement of the letters here what they do. So Prepend essentially inserts an item at the beginning of the list, and Append inserts an item at the end of the list. So what does this mean? So essentially this means that when we prepend, we want to create a new node right here with some kind of data, right? And a pointer that points towards this guy, the old head, right? Because this one is the new head on, this guy is the old head, right? And the append function, what the append function does is it essentially creates an item at the end of the list by creating a new node. So the new node is gonna have some data, which we don't know, and a pointer, this guy is now gonna point towards null. And the previous node, the previous tail, which is now an old tail, which we don't really care to count anymore, points towards the new tail. This guy is the new tail right here. So how would we go about implementing this? So let's start with the prepend function. We've seen that we somehow have to call to temporarily name this the old head, so we can create a reference to it, so the new head can point towards the old head, right? So what we're just gonna, I know they sounded very complicated, it's very simple. Let me just write it and you're gonna understand why. So we're just gonna also have some data so we can call it. So we have a node pointer old head, right? It's gonna be the head. So the head now is gonna be equal to a new node that's with data. So it holds the actual data inserted by the user, and it's gonna point towards the old head. So we essentially did this. We created this variable. We couldn't just have done this, right? Because then we wouldn't have an actual reference towards the next node, the previous head, which is now gonna be the old head, which is not a head anymore, right? So if we do this, then we essentially create a new connection between a new node, which we're creating, and the previous head. And then we can just increment the length. So the prepend function has now been implemented. Let's try and implement the append function, right? It's gonna be, again, it's gonna take some data. So this means that we have to insert at the, let me just comment here right now. Insert at the beginning of the list, sorry. And insert at the end of the list. So what we're essentially doing with the append function is we're just gonna create the new node directly, right? So it's gonna be final node, whatever. It's gonna be a new node with data and a null pointer. Remember, we're just gonna create this directly. This is the new node which we're creating here, right? So it's a data which is going to be input by the user, pointing towards null, right? All we have to do right now is to make the previous tail, that the next node of the tail is going to be final node, so it doesn't point towards null anymore. And we should also realize that the tail is now final node, so we can just keep adding items at the end of the list, because if we don't do this, then this guy is still gonna remain the tail, which we don't want. So we want to make this the tail, right? The last item. Let's see. There we go. And let's not forget to also increase the length. There we go. That should be good. So let's try and see if these functions are actually working right now and test our logic. But before we do that, let's actually create a function that can just pretty simply print all the items inside the linked list, right? Because that's gonna be pretty easy for us to tell. So let's create a void print items, right? There we go. So let's just we're just gonna make a simple while loop, which is just gonna loop through all the items, which we're gonna say current node equals to head, and then while current node is not equal to new pointer, well, then we wanna just standard cout current node data, and then we can also end the line, so we have some nice visuals. Current node, next node, so it's just current node equal to next node, right? So let's just see what's going on right here. So we're taking a hold of the first item of the list, and then we're essentially looping through all the items until we hit null pointer. And when we hit null pointer, that means that the list comes to an end, because as I've said in the beginning, it's null terminated. It should print items. There we go. Let's see. We should get a 5, right? Let's see. 5. Awesome. Let's see if we can add some more items right here. So let's test the actual functions. So L prepend. So this means we're going to add at the beginning of the list. So let's add a 3 at the beginning. Let's see if it's working as intended. 3, 5. Awesome. Let's maybe add another one just to see if the connections were also made properly. Let's add a 7 at the beginning. Let's see. So we have 7, 3, 5. Awesome. Now let's also test if the append function is working. Append 9. Let's see. We should get the 9 at the end. Awesome. There we go. And let's also add 12, for example. This means we should also get a 12 at the end. Let's see. There we go. Awesome. So we have a prepend, an append function, and also PrintItems function that they all work properly, right? So prints all items from the list. So just like it's clear for everybody, pretty much, right? Now let's say you want to insert something in the middle of the list, right? So this would be a bit trickier, right? Because you also have to deal with the index that we want to insert to, and we have to also traverse the list to get to that point, right? So this would be a bit more tricky, let's say, right? Well, not really. Let's just look and see. So this guy is at index 0, this guy is index 1, index 2, and index 3. Pretty cool, right? So let's say we want to insert something at index 2. How would we go about doing that? So we want to create a new node, essentially, with the data and obviously the whole things, the whole shebang. And we want to just break the connection between the previous node, which is 1, and we want to connect it to the new node. So this essentially becomes index of 2, this guy becomes 3 and 4. This guy simply points towards the following item, and we do need to create some kind of mechanism through traverse and reach this guy so we can modify the pointer, right? So we need to create a function that would return the pointer towards that node. So we have to return a node pointer. Let's see traverse, right? Traverse to index, for example. Let's take an index. So we need to create some kind of a variable that would be like the iterator, right? So let's say int counter, which is going to be equal to 0 at the beginning. And we have to say something like while counter is not equal to index. Right? Well, then we obviously want to increase the counter, that's the first thing. But we should also iterate through, traverse through the list somehow. So taking basically the same approach that we did right here, we just have to do the node pointer, current node is equal to head, right? It's the same kind of syntax that we're gonna do. And we're just gonna say current node is equals current node next node, right? And when this breaks out of the loop, we wanna just return current node, right? So this should give us, if we input here 1, this should give us the actual pointer, this guy, right? Now, notice that when you wanted to insert something at the second item, you needed to get the previous item, right? So it's gonna be we need to get the index minus 1 item. All right, so let's just get straight to implementing the actual insert function, which obviously is going to take 2 parameters, right? So we need to have the index, where we want to insert the item, and the actual data, which we want to insert, obviously. So what we have to do is to create a reference towards the, remember, previous node, so this guy right here. So that means we must traverse to index 2 minus 1. So index minus 1 we have to do. So we'd go node, previous node equals traverse to index of index minus 1, right? So that should give us a reference to this particular node. And you could also just grab a reference of this one, and you'll see exactly why. So let's say node next to next. So this essentially means we're grabbing a reference to this guy right here, because we haven't yet done the change, right? So we're grabbing a reference of this, where we can say node next node equals new node of, it's gonna be a bit confusing right now, but just bear with me, okay? So new node of data and pointing at the next node. Now, let me just explain 1 second. What's going on here? You know what, let me just rename this so it might be a little bit clearer for you what's going on. So I don't want to make this I don't want to make this harder than it is, you know. So let me just do this, and then let's go to node. Alright, so let's consider this guy the left node and this guy the right node, because it's gonna be a little bit easier this way, right? So we said that we find the left node, then we reach the right node by doing left node dot next node, which is gonna be this connection right here, because we haven't yet created the new connection to the new node. Hopefully that makes sense. And after we've done that, we essentially have a reference to the left and the right node. And then all that we're doing is we're pointing the left node towards the new node, which we're creating. And then the new node, we're pointing it towards the right node. So, you know, we should not forget to increase the length. Now, what happens if the index is 0? Or actually, even the length of the, let's say someone puts the index, I don't know, 5. What happens then? So, what we should do is we should create some edge cases, right? In which case we're gonna say if index is equal to 0, well then we wanna append data, right? Because there's no point in doing all of this when we already have a function that deals when someone puts the index 0, right? Oh yeah, we should do this because we wanna append and return. We don't wanna continue running the next things. Index is gonna be greater or equal to length minus 1. Well, then we're just gonna prepend the item, right? prepend data, and right, so after we've done that, then we could just like come in here and handle edge cases. There we go. And after that's all done, this should be all right. Now, you may have also noticed that this guy is O of 1 complexity. This guy is also O of 1. However, when it comes to inserting items, we are already at O of n complexity because we have to traverse, right? So this is O of n. So this is also something which you should keep in mind, right? So let's say we want to create the remove function. Now this is where, at least in C++, it gets a little tricky because we also have to like handle memory and stuff. But I think it's really cool. Let's see how we could actually do this. Index. Again, this is just my implementation of stuff. I hope this is correct, right? I hope I'm handling all the memory correctly in here with the pointers and stuff. I'm telling you, with C++, I'm still learning, right? Let's say we want to remove this node, right? So this guy points to this guy points to this guy, and this guy points to... So what we have to do when we delete this guy is we must make this guy point towards this guy, previous node, which is gonna be traverse to index, again, index of -1, because we wanna grab this guy. What we should do, we wanna go node, actually let's just keep the same names as we have created them in the insert function. Left node and right node equals to left node. Now notice how we have to traverse it 2 steps, because we have to skip this guy, right? So we want to do right node equals to left node dot next node, and then we want to do another next node. All right. Delete left node dot next node, right? And then left node dot next node equals to right node. Sorry. All right. And then we want to length minus, right? So let's handle the edge cases, right? So if index is equal to 0, so if we want to remove the head. So again, similarly to what we've done before, old head equals to head. Why do we need to do this? Let me just draw another board right here. This node, and this node, right? We want to remove this guy. All right, then we want to say head equals head next node. I want to delete all head, and we should also make sure the pointer is null so we don't have any kind of error. And then we want to length minus and return so the function doesn't keep on continuing afterwards. So what have we done here? Let me just explain it real quickly. This guy is the head, but we also make it the old head, right? So we have a reference to it, which I'm gonna explain right now. When we say head equals to head.next node, we essentially make head this guy, right? Now, normally this should be enough for languages that don't handle, for languages that have like garbage collectors, but with C++, we obviously don't have that, so we have to still have a reference to this guy, so we can actually delete it out of memory and make sure the pointer becomes null, so we don't have any kind of issues with that. So the next edge case, if index is greater than or equal to length -1 again. So if someone wants to delete the last item or put something even bigger than the last item, which wouldn't make any sense. So you have again the 3 nodes, 1, 2, 3. This guy is the tail, right? So which pointer do we need right here? What do we need? What do we essentially need to get? We need to get a reference to this pointer right here, right? So we can essentially point it to null and also delete this old pointer which is right here. Node pointer penultimate node equals we want to just traverse to index. We want to do length -2. Now let me just explain right here. If we were to do length -1, we would get this item right here. But we don't want that, right? We want to get a reference to this guy right here. So we do length -2, because length -1 is obviously the length of the linked list, right? Penultimate node, next node, we have to delete, right? So we want to delete it from memory. And then we also want to make penultimate node, next node, point towards a null pointer. And then let's not forget that we must also make this penultimate node, which is now the last node, we want to make it the tail, right? So penultimate node, there we go. And then we should also remove the length again of the list and then so it doesn't continue. So why do we grab this node actually? So we essentially grab that node and not just the last node directly, because after we have deleted this node, which we're doing here, right? We must also set this as the null pointer to point towards null, and we must also, very importantly, put this as the tail, right? Because if we just delete this, then we also delete the tail, which is gonna it's gonna create also all sorts of issues, right? It's gonna make the list unusable. All right, so if this helped you, don't forget to like and subscribe, because it genuinely helps the algorithm and to grow our little army to army of coders. And again, I'm still learning with this whole memory management thing. I hope I did it the right way. I hope I did. If you're a C++ expert, please let me know if I did it the proper way. Yeah, I wanted to challenge myself with creating it in C++, and it was honestly a blast. I've had a blast. It was really fun. And yeah, so that was me. Peace out.